is adjacent to this 2. Similarly, 4 is adjacent to 6. This one is adjacent to this. This one is adjacent to this. Okay. Now, let us try to see this one and this one. This is what? This one is 0011. What is this? 1011. So 0011, 1011. In how many positions they are changing?
1.
1. So this is also adjacent. This adjacent to this. This adjacent to this. This adjacent to this. This adjacent to this. Okay. So now if they are adjacent, then they can form a pair there. Now, one second. Now, this one is adjacent to this. This one is adjacent to this. This one is adjacent to this. Okay. So, four corner of this K map, they are adjacent to each other. So, they can form a quad because 0 is adjacent to 2, 2 is adjacent to 10, 10 is adjacent to 8, 8 is adjacent to 0. So, all are adjacent to each other. So, they can form a quad. Similarly, suppose this 2 and this 2. 4 is adjacent to 6, 6 is adjacent to 14, 14 is adjacent to 12, 12 is adjacent to 4. So they can also form a quad. Okay. So we are only seeing about which are adjacent to each other. So what we identify? Each corners are adjacent to each other. Four corners are adjacent to each other. And this one end is adjacent to other end. Okay. This to this side also, and this vertically also. This one is also adjacent to this. This one is also adjacent to this. But they are not adjacent diagonally. They are not adjacent diagonally. These are not possible. They are not adjacent to each other, which also happened in case of 3 variable K-map. So now here, if we'll check for the combination, any octet possible here where 8 adjacent cells where there will be 1? In 8 adjacent cells, is there any 1 available? Is it available? कहीं पे है 8 adjacent cells where you will get 1. This is and this 4, they are adjacent to each other. Yes or no? 0 is adjacent to this, 0 is adjacent to this one is adjacent to this one is adjacent to this, 2 is adjacent to 10, this is adjacent to this, 11 is adjacent to 9, 9 is adjacent to 8, 8 is adjacent to 0. So they are adjacent to each other. So what happens? This can be an octet, combination of 8 cells. Apart from this, any other octet possible? Apart from this, any other octet?
No, sir.
देखो, may be possible.
Yes, sir.
This can be a 8 ones which are adjacent to each other. All are 8 are adjacent to each other. Okay. So 2 adjacent cells. So 2 octets are possible here. Okay. Now let us try to write the function. So what will be function? So function will be first for this pink color octet. So is there anything common in vertical side, CD side? Which common hai? Which will be C value of CD, which will be common to all the cells? Here in this octet, is there anything common inside of C and D, which will be common for all the cells? CD equal to 0, 0. Suppose CD equal to 0, 0. It is here only. But for this one, CD value is not 0, 0. Similarly, CD equal to 0, 1. This is for here, but for other places it is not same. So nothing is common inside of CD. In case of AB, is there anything common? In this 4, AB value is 0, 0. Here for this 4 ones, AB value is 1, 0. Okay. So is there anything common here? So the second 0 is common. That means b equal to 0 is common for all the 8 ones. Yes or no? Verify. For all the 8 ones, is it the value of b to be 0? Is it correct?
Yes, sir.
Yes, sir. So what we are doing? We are solving using SOP. In SOP, what happens? X bar tends to 0, x tends to 1. So here b is equal to 0. So what happens? For this octet 1, what we can write? B0 means क्या लिख सकते हैं? This will be b bar. Similarly, octet 2, check and tell what will be common octet 2. Is there anything common in AB side? Anything common in AB? कुछ कॉमन होगा AB में येलो कलर ऑक्टेट के लिए? कुछ भी कॉमन है? Either AB equal to 0 0, AB equal to 0 1, AB equal to 1 1, AB equal to 1 0. Anything common either in A and B? But it has to
No,
be
sir.
nothing.
No, sir.
Out of CD, this two 0 1 1 1. So what is common? The second one is common. Second one corresponds to what? Yes.
सर कॉमन कैसे रहते हैं वो बता दीजिए.
Common means it is nothing about the commonality. Common is you need to find out of A, B, C, D, which one is will be same for all the cells. Whatever combination you are making, for those combination, what is the common value of A, B, C, D? Okay, so see this octet. So in this octet, these 8 ones are present. So this 2 ones, AB is 0 0. For this 2 1, what is the value of AB? AB is 0 1. So from here only we understood it AB is not common. AB is not common because values are changing. It is not same. Here AB is 0 0. Here AB is 0 1. Then here AB is 1 1. Here AB is 1 0. So nothing is same for them. Neither value of A and B remains same for all the 8 ones. But now if we see in place of CD, for this 4 ones, second column, value of CD is 0 1. Third column 4 ones, CD is 1 1. So what is common? If you observe, the second one is common for all the 8 ones. Verify. Is it same or not? Is it same?
Yes, sir.
See this, for this also D, this 4 ones of third column also D equal to 1. So what happens? So for this octet, D equal to 1, D equal to 1, we are writing for SOP. So what will happen? Octet 2 will be D. So combination 1 we got B bar, combination 2 we got D. This is SOP. So each expression needs to be added. So what will be the output? Output will be B bar plus D. Okay. The same thing is mentioned here. Okay. So in this way we can solve different questions. Now let us try to solve this question. Let me first write this is 0, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So this is given in terms of summation of m. So what to do? We need to put 1 or 0 in those positions.
1.
1. 8, 9, 10, 12, 0 will be 1, 2 will be 1, 2 12, 13, 14. Okay. Now check carefully and tell what combinations are possible. Obviously combination 16 is not possible because 16 ones are not present. Any octet possible? Any octet possible? Any 8 adjacent ones? कहीं पे है 8 adjacent ones?
Yes, sir.
Where? This one. This 4 1, this 4 1 are adjacent to each other. Any other octet? No other octet is possible. Then any quad possible? Combination of 4 adjacent cells. This can be a quad. These 4 cells are adjacent to each other. Okay. Any other quad possible? Any other quad possible? Combination of four adjacent cells?
No, sir.
No,
No.
sir.
Pair possible? This can be a pair. Okay. Now, if we'll write first for octet. For octet, is there anything common in AB? Anything common in AB side? Some value which will be common for all the 8 ones. AB साइड में कुछ कॉमन है?
No, sir.
CD में here CD is 00 first column. Fourth column CD is 10. So what is common for all 8 ones? The second 0 is common. Second 0 stands for what? D.
D.
That means what? D equal to 0 is common. We are solving for SOP or POS? SOP. So in SOP x bar is 0, x is 1. So what can we write? D equal to 0 means क्या होगा? Expression for octet 1?
D bar.
D bar. Next, let us see for quad. For this quad, is there anything common in this AB side? This two?
Yes, sir.
क्या common है?
One. One.
This first one is common. This one corresponds for what? A.
A.
In CT side, anything common? 0, 0, 0, 1. What is common here? This C equal to 0 is common. So A equal to 1 is common. C equal to 0 is common. So these values are common for all the 4 ones. So this is sum of product. So each combination will give us a product term. A equal to 1, C equal to 0. So what can I write about this quad? This will be how much? A equal to 1 means what? A bar or A?
A.
A. C equal to 0 means C bar.
D bar.
So it will be A dot C bar. Last, this pair. What will happen for this pair? For these two ones, what is common? AB side. Both 0, 1, 1 is common. A equal to 0 is common. B equal to 1 is common. All of this is common. Out of CD, what is common? 1, 1, 1, 0. So this first one is common. First one means C equal to 1. So for this combination, A value is 0, B value is 1, C value is 1. So for this pair, what I can write? 0 means A bar or A?
A bar B.
Just see this. This is A bar dot B dot C. So what will be the reduced expression? This will be D bar plus A dot C bar plus A bar dot B dot C. Okay. Another thing to remember here, now why we are forming a bigger combination. Now instead of that octet, we could have formed two quad also. Yes or no? Here I formed a octet. Instead of that, I could have formed two quads. So what happens? See this. This is a octet. So because of that, what happened? What is the expression you got? You got D bar. You got D bar. Okay. Now you formed here a quad. What is the expression? A dot C bar. Here you formed a pair. You got A bar dot B dot C. Now in this expression, first, how many inputs are present here in a octet? कितना input है? 1, 2, 3, 4. How many inputs are there? तो कितना input है? One है. Here 2. Here 3. So when you are forming a bigger combination, you are getting on like octet in a 4 variable K map, you are getting 1. When you are forming quad, you are getting 2 inputs. When you are getting pair, you are getting 3 inputs only. In this expression, you are getting only 3 inputs. So obviously forming bigger combination, your expression will be reduced. Now suppose instead of that octet, I would have formed 2 quads. So क्या होता? You have got this kind of 2 expression. Okay. So obviously which will not be in a minimized form. So we should always try to form a bigger combination. Same one. Next, let us try to this question. It is given pi of 2, 8, 9, 11, 12, 14. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So here in this question mentioned pi of capital M is numbers. So in those numbers I need to put zeros or 1.
0.
We need to put 0. 1 second. So what to do? 2. 2 is this. 8, 9, 10, 11, 12, 14. Okay. This is two part in this question. First, reduce the expression and implement using the universal gate. Okay. So remember, if we are solving POS, it will be easier to implement using NOR as we discussed previously. If it is SOP, it will be easier to implement in NAND. Suppose question would have been there, reduce the expression and implement using NAND gate. तो क्या करते? इसको SOP में solve करते. We need to solve using the SOP. Unless and until it is mentioned otherwise. Okay. Now, try to form combination. Move yourself. So, any octet possible here? Any octet? Any 8 adjacent zeros? No. Any quad possible?
Yes, sir.
How many quads possible? This can be a quad. Any other quad possible?
No, sir.
Check properly. Other quads are possible. They are adjacent. It can be also a quad. These two are adjacent. 14, 10 is adjacent. 12, 14 is adjacent. So all are adjacent to each other. Okay. So this quad is possible. Any other quad possible? No. Next, any pair possible?
Yes, sir.
These 2 and 10 are adjacent to each other. So they can form a pair. So this, they can form a pair. Now we are dealing with POS. So in POS, what happens? X bar is 1, X is 0. So first let us start with this green color quad. Quad 1. So for this quad 1, is there anything common in CD side? Anything common? Anything common? CD side में कुछ common है? For all, nothing. In AB, what is common? This 1, 0 is common. So for this quad 1, A is equal to 1, B is equal to 0. So now we are going for POS, product of sum. So each expression will give us sum term. So A is equal to 1, B is equal to 0. So what to write? What will be the expression for this then? 1 means what? A equal to 1 means what?
A bar plus
A bar plus B. Next, quad 2. In quad 2, what is common? This. In AB side, it is common 1, 1, 1, 0. So A equal to 1 is common. In CD, 0, 0, 1, 0. So what is common? क्या common है?
C.
Second 0 is common. Second 0 is for D. So A equal to 1 common. B equal to 0 common. So what I can write for this quad 2? A equal to 1 means what? A bar or A? क्या लिखूं? A equal to 1. Just
A bar.
compare with this. This will be A bar plus B equal to 0 means B. Last, for this pair, AB value is 0, 0 here. This one here, AB is 1, 0. So what is common? Second 0 is common. That means B equal to 0 is common. And 1, 0 is common. CD 1, 0 is common for both the cells. So C is equal to 1, B is equal to 0. So what I can write? I can write that B equal to 0 means B or B bar? B equal to 0 means compare this only, this one. So this will be B plus
C bar.
B bar plus D.
D.
This is product of sum. So final expression will be multiplication of all this. So result will be A bar plus B multiply with A bar plus D multiply with B plus C bar plus D. One second. Okay. So this is expression. So we reduce the expression first part. What is the second part of the question? Second part of the question is to implement this using universal gate. So this is POS. So it will be easier if we'll implement this using NOR gate. Okay. So क्या करना पड़ेगा? In previous classes we discussed how to do that. क्या करना पड़ेगा? Why it is easier in POS? If you go for NOR implementation, they are nothing but two-level implementation. क्या होगा? A bar plus B. So basically you will take three NOR gates. First one will be A bar B. Second will be A bar D. Third will be B C bar D. So this will be two-level implementations only. कैसे उसको करते? फर्स्ट स्टेज होता दिस वन इज व्हाट और गेट, देन नेक्स्ट स्टेज क्या होता एंड गेट. वी डिस्कस दैट और गेट कैन बी चेंज टू नॉट गेट, और गेट कैन बी चेंज टू नॉर गेट बाय एडिंग ए इन्वर्टर. Similarly, bubbled AND gate is same as NOR gate. So all those gates needs to be replaced with NOR only. So this will be two-level implementation. For simplicity here, I have not implemented this complemented. Okay. Exam, you need to implement this inversion also with the help of NOR gate. So next is another question. Okay. So same question. It is asked that implement this using NAND gate. Implement this using NAND gate. So what to do? If question comes using NAND gate, then we should solve using the ones. Okay. So already it is mentioned. क्या होगा? You can see clearly here how many quads are possible. 4 quads are possible. 4 quads are possible. So you can write the expression. Once you write the expression, you can implement this using the NAND gate. What will be this NAND gate implementation? कितना NAND gate लगेगा? कितना NAND gate लगेगा इसमें? How many NAND gates will be used? How many NAND gates will be used here? कितना? All these are two-level implementation. All these are two-level implementation. So what to do? How would have solved this? First, we should have implemented this using AND gate and OR gate. So how you can implement A bar B? What do you require to implement A bar B? Which gate is required? Which gate is required to implement A bar B? AND gate or OR gate?
And gate.
AND gate. 1, 2. How many AND gates will be required?
4.
4. So this will be A bar B. This will be A bar C bar. Third will be A bar D. Fourth will be BD. I am writing from this expression only. Then all these are added. So how I can add them? What gate is required?
OR gate.
OR gate is required. I want to implement this using help of NAND gate. So what to do? I can use bubbles here. If I use bubbles, and becomes NAND. But I cannot use one bubble. To compensate for that, I need to use another bubble here. So now this OR gate becomes bubbled OR. What is bubbled OR? Bubbled OR is same as NAND. So these are called as that two-level implementation. That's why instead of being like this, directly we can draw this circuit. A bar, C bar, all this needs to be implemented with the help of NAND gate. For simplicity, I am not showing here. Okay. So this question already done. Okay. Next one. So now we'll go for a next one, little bit complicated ones. So till the time what we discussed, how to solve the K-map. First of all, we'll fill ones and zero. Then depending upon what we want to solve, SOP or POS, if we want to solve using SOP, we'll form the bigger combinations using one. If we want to solve using POS, we want to make the combination with the help of zero. Always we used to try for the bigger combination. Okay. Now what to do? See here. This is a question given. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So in these places, I need to put 1 because it is given in terms of SOP. Summation of m is given. So 3 is 1, 4 is 1, 5 is 1, 7 is 1, then 9 is 1, 13 is 1, 14 is 1, 15 is 1. So next I will try to form a combination. Any octet possible here? Octet. Any 8 ones which are adjacent to each other? Any 8 ones which are adjacent to each other? Possible hai?
No, sir.
No. Any quad possible? This can be a quad.
Yes, sir.
This middle one can be a quad. No other quads are possible. Next you can see 4 pairs are possible. Okay. Now, in the 3 variable K map, we discussed about essential combination. Which combinations are said to be essential? If at least single one can be covered, at least single one can be covered using that combination. Using that combination. If using any combination, if at least single one is present which can be covered using that particular combination, then that combination is said to be essential combination. Otherwise, it is not. So here, first check from the bigger ones. First the quad. Find out, is that quad essential? Is there any single one in a quad which is covered using quad only? There is no other way. This one. It can be covered using how many combinations? कितना combination में cover हो रहा है? Suppose this pair is 1, this pair number is 2, this pair number is 3, this pair number is 4. So this one can be covered using which combination? It is covered using quad? Yes or no? ये one ये quad में cover हो पाएगा. Apart from that, it can be covered using this pair number 4 also. Yes or no?
Yes, sir.
Next, this one it can be covered using how many combination?
2.
2. Quad or pair number 1. This one again 2, either in quad or this pair number 2. This one, how many combination will be able to cover? Either quad or pair number 3. So see this in quad. All the ones they can be covered using 2 possible combination. 2 possible combinations. So what happened? This quad is not essential. Quad is not essential because all the ones can be covered using other possible combination. Okay. Now check for these pairs. Are these pair essentials? Pair number 1. Is it essential? Is it essential? Pair number 1.
Yes.
Why?
Yes, sir.
Because of this one. This one can be covered at star mark. It can be covered only using this pair number 1. There is no other way. So it becomes essential. Pair number 2. Is it essential? Is it essential? Pair number 2.
Yes, sir.
Why? Because of this one. This one can be covered using this pair number 2. Similarly, pair number 3 is essential because of this one. Pair number of 4 is essential for this one. Okay. So what happens? All 4 pairs are essential. So what to do? So again I am drawing this K map. Okay, and I am forming those combinations. 1, 2, 3, 4. Quad is not essential. Now when I see, check here, all the ones are already covered. All the ones are already covered using the essential pairs. Essential pairs. So that quad is a bigger combination, but because it is not essential and all the ones are already covered, so because of that we'll not go for the bigger combination. We'll not go for the bigger combination. So result will be this 4 pairs. This expression is mentioned here. So now onwards what we do, we'll follow these steps. What are the steps? First we'll form all the combination. You'll find out all the combination. Next, you will check for the essential combination. Once you identify essential combination, then you will see how many ones are covered. Suppose some ones are not covered. Some ones are not covered. Then what to do? Then you need to cover those ones using minimum number of combination starting from the bigger one. Okay, so now onwards we will do like this. So this combination, bigger combination, we are not using this. This is called as a redundant combination. Redundant combination. This is not essential, neither selective. So this combination will be called as a redundant combination. Is this point clear? It is a bigger combination, yet we are not taking this. Why? Because it is not essential and all the ones are already covered. So because of this, we are not going for that. Okay, is it clear? This is important. Is it clear?
Yes,
Yes,
sir.
sir.
Let us try to solve another problem. So you do it yourself. First tell me here how many combinations are possible. Any octet possible here? Any octet possible here? 8 ones which are adjacent to each other.
No.
No,
Any quad possible here?
no, sir.
No.
No.
Pairs are possible. Count and tell how many pairs will be possible. How many
Six pairs.
pairs? Huh?
Six.
6 pairs are possible. So 1, 2, 3, 4, 5, 6. So this red color one, I will call this pair number 1. This one I will call this pair number 2. Yellow I will call this pair number 3. Yellow pair number 4. This pink 5. This pink 6. So out of those 6 pairs, which pairs are essential? Which pairs are essential? Pair number 1. Is it essential?
Yes, sir.
No.
Okay. If yes, why? If no, why? Okay, no, why?
Because of the first one.
Because of this you are talking.
Yes, sir.
It would mean essential, na? This single one can be covered only using this pair. There is no other way. There is no other way. So because of that, it becomes essential. Using no other possible combination, we can cover that one. So it makes this to be essential. Similarly, pair number 2, red color below one. Is it essential?
Yes.
Why? Because of this one. See that star mark? This one can be covered using this pair only. Other pairs, is it essential? Other pair, is it essential?
No.
No, sir.
You can see any other pair, neither yellow color nor pink color. Just find out all the ones. Those ones can be covered using multiple way. If I'll say this one, this can be covered using red color, yellow color. This one can be covered using pair number 3 yellow color, pair number 5 pink color. This one can be covered using pair number 5 pink color or yellow color number 4. This one can be covered using two-way yellow color 4 number or pink color 6 number. So they can be possible to cover using multiple ways. So all the remaining quads are not essential. So next what to do? Let me draw again. 1, 2, 3, 4. So who are essential? Those two are essential. So using essential pairs, how many ones are covered? How many ones are covered? 4 ones are covered. So basically I am following this step only. Okay. First I find out all combination. कितना हुआ? 6 combination. Then I find out essential. How many essential we got? We got 2 essential. Then I need to check how many ones are not covered. So how many ones are not covered yet? How many ones are not covered? 3 ones are not covered. 3 ones are not covered. So what is the next step? We need to cover those ones using minimum number of combination, that to the bigger combination. So in how can I cover these 3 ones? Is it possible using, because I don't have any quad and octet, I only have pair here. In how many ways I can cover all those ones? Is it possible using one pair?
No, sir.
No. So minimum कितना चाहिए होगा? How many pair will be required to cover this? 2. So that too can be different answers are possible depending upon my wish. So suppose someone can go for this one and this one. It is up to them. So it can be one answer. Okay. Or or maybe someone can go for this. Someone can go for this. This can be a possibility. Okay. So multiple ways are possible. But anyway, you need to go for 2 pairs. Okay. So what is the name of this combination? These combinations are called as selective combinations because we can choose among them. Out of those 4 pairs, we can choose any 2. We can choose any 2 such that we can cover all the ones. Okay. So up to this, is it clear? Everything about 4 variable K map? Is it clear?
Yes, sir.
Yes, sir.
So next we'll go for the next part of the K map. So it comes with don't care combinations. Don't care combinations. So if you remember about BCD, what is BCD codes?
8421.
84. Natural BCD is 8421. So why we are using BCD? To represent 0 to 9. So how are representing? Using this 4-bit binary codes. Using this 0100, this is for 0 1 2 3 4, for 5 0101, 6 0110, 7 0111, 8 1000, 9 1001. So in 8421 BCD, we are representing from 0 to 9 using this 10 combinations. So how many binary numbers we are using? 4 binary numbers we are using. 4 binary numbers we are using. If you are using 4 binary numbers or 4 inputs, how many possible combinations will be there? Using 4, how many possible combinations? ये 4 पोजीशन है. So how many possible combinations will be there?
16.
16 possible combinations. So out of 16, how many we are using? We are using 10. So what happens to remaining 6? We call them invalid. So this 1010 is invalid, 1011 is invalid, 1100 is invalid, this is invalid, this is invalid. These 6 combinations are invalid. Okay. So what do you mean by a truth table? What is the definition of a truth table? What is a truth table? Truth table क्या है? So many truth tables we wrote now. What do you mean by truth table? Truth table tells about what? Truth table is a combination of all the possible inputs and its corresponding output. All possible input combination and its corresponding output. Now, when in next chapter we'll see for this circuit design. Now, suppose I have a system. I don't know what is the system. Some system I am designing. Okay. In this system, I am applying the BCD input. So, how many inputs I will have? I will have four inputs, and I will have certain output. Okay. So, in BCD input, how many inputs we have? We have these four inputs. So, how many possible combinations we have? 16 possible combination. Okay. But out of 16, what happens to this 6? These 6 are invalid. These 6 are not a valid input. These 6 are not a valid input. But when I am writing a truth table, I need to incorporate that. Truth table is nothing but it is a tabular form. We are writing all possible input combination and its corresponding output. So when you are giving BCD as an input, these six combinations you will never get. These six combinations you will never get. So its output is of no consequence. Okay, because you cannot apply this as an input, so its output is of no use. So in that case, what we used to do, we used to call them as don't care combinations. We used to call them as don't care combination. And its corresponding output is denoted as cross. Cross, or we can write D, or we can write them as phi. So point is that we cannot use them. So that is of no use of it. And at the same time, when you are writing truth table, you are writing all possible input combination. Okay. So those combinations are called as a don't care combination. Let us try to understand this using another example. Now suppose in your hostel or in your house you are staying. Now suppose you have three LEDs. Okay. Now if you have three LEDs, what can be the output of a LED? LED can be on or LED can be off. Yes or no? What happens in LED? If you switch on, LED will be on. If you switch it off, LED will be off. So suppose LED 1, LED 2, LED 3. So LED 1, what are the possibility? It can be on or off. LED 2, it can be on or off. LED 3 can be on or off. Okay. So on means what? On means it is 1, off means it is 0. So now these are my three inputs, L1, L2, L3. So how many possible combinations are there? How many possible combinations LEDs can be on or off? कितना combination होना चाहिए? What are the possibilities?
8,
8 possibilities. What are those possibilities? Triple zero, all LEDs are off. Double zero one, only L3 is on. 010, only L2 is on. 011, L2, L3 is on. 100, only L1 is on. 101, L1, L3 is on. 110, L1, L2 is on. 111, all the LEDs are on. Okay, so these are all possible input combination. These are all possible input combination. Now, suppose I want to design a circuit. I have these three LEDs as an input, L1, L2, L3. In the output, I want to design an alarm circuit. So this alarm will be activated when there won't be sufficient light inside the room. Again, I'm repeating. I want to design a circuit where this output is a alarm circuit. So alarm will be activated when there won't be sufficient light inside the room. So when there won't be sufficient light inside the room, so I define that if more than equal to 2 LEDs are on, then there is sufficient light intensity. If less than 2 LEDs are on, then light intensity is not sufficient and alarm should be activated. Okay. So who is your output here? Here your output is alarm. So I'm representing it with F. So alarm activated means alarm will be on. It will produce a sound or buzzer when there won't be sufficient light intensity. So in that case, what will happen? Output will be 1. When there will be no sound, output will be 0. So check this first combination. Here how many LEDs are on? Here how many LEDs are on?
None.
None. So what will happen to the light intensity inside the room? Is it sufficient light?
No, sir.
No. So what will happen to buzzer? It will be activated or not activated?
Not actually.
There will be sound. Buzzer will be activated. So if it will be activated, what will happen to output? 1 or 0?
1.
1. Great. Next example. How many LEDs are on?
1.
L3 is on. Single LED L3 is on. What happens to light intensity? No sufficient light. No sufficient light means what happens? Output will be क्या होगा?
1. 1.
Alarm will be activated. 0 1 0.
1.
Again 1. Great. 0 double 1. How many LEDs are on?
0.
2 LEDs are on.
2.
L2 L3 is on. If 2 LEDs are on, sufficient light is there. There won't be any alarm activation. So it should be 0. 1 double 0.
1.
1. Because only L1 is on, so buzzer will be activated. 101.
0.
2 LEDs are on, so there won't be any buzzer. So 0. 110. Again 2 LEDs are on, so buzzer will not be activated. 111. All LEDs are on, sufficient light, so buzzer will not be activated. So what can I write about this function? This function is summation of m. What? This is what? 0 to 7. So 0, 1, 2, 4. Okay. Now this is a normal example. This is a normal example. We designed a circuit depending upon the LEDs on or off. Your buzzer will be activated, alarm will be activated. Okay. Is this example first clear? Then we'll introduce a don't care here. First of all, up to this much, is it clear?
Yes, sir.
Okay. Now what happens? Now I'm adding something else. Some constraints. Now suppose this L1 in your house, what happens? This LED is a faulty LED. This LED is damaged. This LED is damaged. If it is damaged, what will happen? Is it possible that anytime this will be on? If it is a faulty LED, damaged LED, can it be on? Can it be on?
Yes, sir.
On होगा कि नहीं होगा? Is it possible that it will not be on? Either you will switch it on or off, but LED will never be on. Okay, because this one is faulty. If this is faulty, is it possible that light will be never be on, LED will never be on? So this L1 equal to 1 is not possible. L1 is equal to 1 is not possible because that LED is faulty. That LED is faulty. But how many inputs we have in the room? How many inputs we have? We have 3 inputs. 3 LEDs we have. We have 3 LEDs. Okay. So how many possible input combinations we will get? Same 8 input combination like this, whatever we wrote. But now there is a catch. What happens? Because that LED L1 is faulty, we will never get this value equal to 1. It can never be 1. So practically, we will never get this combination. But in truth table, we are writing all possible combination. But practically, we will never come across this combination because that L1 is faulty. So what happens? These combinations are called as don't care combination. Okay. And what we used to do? Its corresponding output, we used to write them as cross or D or phi. Cross D or phi. It is of no use. It is of no use. For the time being, it is of no use. Because for this example, you can see that light can never be on. L1 can never be on. So how does it make sense output is 1 or 0? It doesn't make any sense. That input is not possible. So output can be anything. We don't bother about that. So in that case, we will write this as crosses. So is this example clear? What do you mean by don't care combination?
Yes, sir.
So how to represent this? So same function now, we can write this as summation of m. This is 0, 1, 2. So 0, comma 1, comma 2. Here we can write this as, don't care as separate entity. We'll write this as plus summation of d. This is 4 to 7. So we'll write 4, 5, 6, 7. Okay. So if I write in terms of pi, so what to do? Pi of capital M. Which terms are missing here? Pi means what? Where you are getting 0? Where you are getting 0? Only this? What is this expression?
8.
3. So just as one simple change we need to make here. Don't care. When you are writing SOP, you can write summation of D. When you are writing POS, you can write this as pi of capital D. 4, 5, 6, 7. Okay. If you are writing SOP, it should be summation of D. If you are writing POS, it should be pi of D. Okay. So we can utilize this for a very useful way. What will happen? That cross, whenever I am writing, I can make that or I can consider that cross to be 1 or 0, depending upon my wish, because those inputs are not possible. So it doesn't make any changes if I consider them as 1 or 0. So when I will consider them as 1, if I can able to reduce the expression with the help of that. If I can reduce the expression with the help of that, I will consider that to be 1 or 0. So we'll see how to do that. So it will be clear if we go for one example. So this is the example. Okay. So it is given, let me first write here numbers. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So what is mentioned here? Summation of m 1, 5, 6, 12, 13, 14. So in these places, what I need to put 1 or 0?
One.
1. So 1 is 1, 5 is this, 6 is this, 12, 13, 14. These places I will put 1. Next, don't care is mentioned 2, 4. So in those places I need to put cross. So 2 is this, 4 is this. Okay. First of all, is this point clear? How to put ones and those crosses?
Yes, sir.
Okay. So next, here we are solving using SOP or POS?
SOP.
SO.
SOP. So how to solve when we'll come across this don't cares? So first of all, if you are solving SOP, then assume that cross to be 1. Assume that cross to be 1 and form all the possible combinations. So how many possible combinations are there? Any octet possible here? Any octet possible here?
No, sir.
No. Any quad possible here? Any quad possible? Quad
Yes, sir.
possible. How many quads will be possible?
Two.
Two quads. Okay. Anything else? Anything else? So this can be a quad. This can be another quad. Okay. Next. No further quads are possible. Any pair is possible? Any pair is possible? How many pairs possible? कितना pair possible होगा?
Two.
Two pairs are possible. This is one. Another one is this. Anything else? Any other pair?
No, sir.
Okay. So first of what I did, because I was solving for SOP, so I assumed cross equal to 1 and I formed all the combination. Formed all the combination. Second step, you check for the essential combination. Is that quad, is it essential? First, that green color quad, is it essential? Green color quad, is it essential? If yes, for which one?
Yes, sir.
It is essential. Because of which one? Because of this one. This one can be covered only using this quad. There is no other possible way. So this quad is essential. Second quad, is it essential? This brown color quad, is it essential?
Yes, sir.
Why? Because of
Because
this one. Then third, this pink color pair, is it essential? Is it essential? कोई भी single one है which can be covered using that pair only.
yes, sir.
This one can be covered using either quad or pair, but this one can be covered only using this pair. Okay. The last pair, is it essential? Is it essential? It is essential. Because of what? Because of this. Because of this. So you have to remember this point. So whenever a combination is getting essential because of cross, you don't consider that. You don't consider that. So second step, you find the essential combination. If a combination is getting essential because of cross, then don't consider it. Don't consider that. Okay. So next step what to do? So how many essential we got? We got three essentials. What are them? This is one combination. This is another combination. This is another combination. Okay. By checking essential combination, now check, is that all the ones are covered? Is it all the ones covered?
Yes, sir.
Okay. Is there anything which is not covered? This cross is not covered. Okay. So there is no harm in that. If a cross is not covered, we can consider that cross to be 0. It is not an essential combination. So here we will consider that cross to be 0. So this will give you the minimized expression. And this expression will be this. Okay. So when we are solving, so what happens in this example? See, this x helps us in reduction. Because of that, we formed a bigger combination. We formed this to be a bigger combination. So we assume that cross to be 1. It doesn't help us. So we consider this cross to be 0. So again, what to do? First, you should assume cross to be 1 if you are solving for SOP. If you are solving for POS, you should assume that cross to be 0. Then you make all the possible combinations. After making all the possible combination, find the essential combinations. Okay. If any combination get essential because of cross, you remove that. Don't consider that. Next check, same procedure. Next check how many ones are covered. If some ones are not covered, then cover using minimum number of combinations. Okay. So in this way, you can minimize the expression. Let us take another example. Same question. Let us try to solve using POS. So let me first put the numbers 0, 0, sorry, 0. This is 0, cross 0, 0, 0, 0, 0, 0. So here tell, is there any octet possible here? Any octet possible? Any octet possible here? Octet possible होगा? Any octet possible? Any
No,
8
sir.
adjacent cells where we get zeros? Not there. Any quad possible?
Yes, sir.
How many quad? Check properly and tell. Don't try to copy it from the left side. More quads will
4,
be possible. 4 quads
4,
are possible. Okay, let's see. One this red color. One this yellow color. All four corners can be a quad. So this will be a pink color. Any other quad possible? Any other
No.
quad possible? Check properly. Someone was telling about four quads. They can be a quad. These two are adjacent to these two. These two are adjacent to these two. Yes or no? ठीक है तो brown color. Next, any other quad possible? No. Any pair possible? Any
Yes, sir.
pair possible? This can be a pair. So these are the all possible combinations. These are the all possible combinations. Next, we have to check for the essential. So which combinations are essential? First start with the red color quad. Is it essential? Red color quad, is it essential?
Yes, sir.
Why? Either
Because
because
of two
of this
reasons.
or because of this. So they both can be covered only using this quad. Okay. Yellow color quad, is it essential?
Yes, sir.
Why? Because of which zero?
The second one.
Because of this. This zero can be covered using only this yellow color quad. Okay. Anything else, is it essential? Anything else, is it essential?
The first
Anything else?
pair.
Okay, pair is essential. But is it essential because of what? Because of zero or cross? It is essential
Zero.
because of this, not zero. Zero can be covered using this quad also, pink color quad. This zero can be covered using either pair or quad. So because of that, it is not essential. It could have been essential because of this cell, but this is a cross. So what I told, if it is a cross, then don't consider it. If some combination becoming essential because of cross, then don't go for that. Then don't go for that. So how many essential combinations we got? How many essential combinations?
Two.
Two. What are them? This one, this one is second. So how many zeros are covered here? How many zeros are already covered? How many zeros are already covered?
Seven.
Seven zeros are covered. How many zeros are remaining? Single zero is remaining. So next, I need to form a combination to fill that zero. Okay. Using minimum number of combination, that to a bigger combination. That zero can be covered using how many combinations? See here. This zero can be covered either using this quad or this pair. Out of this, which is a bigger combination, quad or pair?
Quad.
Quad. So we'll go for this quad. Okay, so this is the answer. So in this case, what happens? This cross helps us in reduction. So we consider this to be 0. This cross doesn't help us. So we consider this to be 1. So we make a combination, a bigger combination using this quad. Okay. This is most important one, and if you are having any doubt, it will be cleared here. This is the very important one. So here question is reduce the expression. So this given in terms of POS or SOP, POS or SOP,
POS.
POS. So I am directly filling this. You can verify later on. 000. Okay. Now check this properly and tell how many combinations are possible here. Any octet possible? Any
Yes, sir.
octet possible here? One octet
Yes.
is possible. This can be a octet. Any quad possible? This can be a quad. One. This can be a quad. Four corners can be a quad. Any other quad possible? This can be a quad. Okay. Apart from this, anything else possible? Apart from this, anything else? और कुछ possibility है? Anything else? So again, what I did, initially I assumed all the crosses to be 0, and I, starting from the bigger combination, I form all the possible combinations. Next, we need to check for the essential combinations. So red color octet, is it essential?
Yes, sir.
Okay. For which 0 is it essential?
For the don't care values.
Again, I repeat that thing. It can be essential because of this, because of this, because of this. But all of them, they are don't care. What I told, if a combination is getting essential because of don't care, then don't consider that. Then it is not a essential combination, because don't care can be 0 or 1. So if something is getting essential because of don't care, we shouldn't take that. So we cannot say that it is essential, because we can take that cross as 1 also. So that octet is not essential. Why? Now सेम क्वेश्चन अगर इसको हम रिपीट कर देंगे, चेंज कर देंगे, सपोज यहाँ पे क्रॉस नहीं होके 0 होता, then this octet is 100% essential, because this 0 cannot be covered using any other possible combination. Okay, but a combination cannot be essential because of cross. Remember, a combination cannot be essential because of a cross. Next, blue color quad, is it essential?
Yes,
This
sir.
quad, because of which 0? Because of this 0. This 0 cannot be covered using any other possible combination. Okay, so this combination is essential. Next, corner quads, is it essential? Corner quad, 4 corner quad, because of which 0? Left corner, right corner, bottom corner, upper corner,
Bottom corner.
because of this 0. It can be covered only using this combination, so it is getting essential. If you observe other quads, they are not essential. Check it. Others are not essential. So what happens? Only these two quads are essential. Okay. So using this two essential combination, how many zeros are covered? Already 8 zeros are covered. Okay. So how many zeros are remaining? How many zeros are remaining?
2.
2 zeros are remaining. So our next target is to cover those two zeros using minimum number of combination. Minimum number of combination, if it is possible, using bigger combination. So can we form a combination? First of all, two zeros are there. So that two zeros, can I, so here bigger combination octet is available. So using octet, can I cover all those two zeros? Is it possible? If I'll go for an octet, can both the zeros be covered? Can we cover both the zeros? नहीं
Yes,
होगा,
sir.
नहीं होगा, कैसे होगा? This is an octet. If we cover using this, only this 0 will be covered, na? Bottom
Okay.
0 how will cover? We cannot cover it. So octet is a bigger combination, but our target is to cover two zeros, and using octet we are not able to do that. Next, is it possible using any quad?
So we can do it by using quad.
So two possibilities are there. Either depending upon my wish, I can go for this blue color quad, or I can go for this green color quad. So in any of the cases, I will be able to cover both the zeros. Okay. So answer will be any three quads. So either you can choose blue color one or green color one. That's why you can see two answers are written. So those two combinations are selective combination. Again here also, octet is a bigger combination, but we are not able to utilize it. अगर octet लेंगे फिर भी तो एक quad लेना पड़ेगा because that zero is not covered. It will not give us a minimized expression. So our target is to cover those two zeros using minimum number of combinations. Okay, so this is another kind of question. This is the last question. Remaining one you will solve yourself. So check the question here. Okay. So what is mentioned here? Here it is mentioned reduce the expression. Previously what we are doing? What kind of questions were given? Directly mean terms or max terms were given. Or maybe a function will be given which will be in a standard form. So from there you can write the mean terms or max term. But what is the problem in this question? In this question, a function is given. So how many variable function is given? It is a
Four.
how many four inputs are there? A, B, C, D. Okay. So is it in a standard form? Is it in a
No.
standard? It is not in a standard form. So how can I minimize this expression? First of all, I need to bring it into a standard form. From that, I can find the mean terms. Mean terms एक बार मिलेगा. Then we can fill this cells with one, and I can solve. So again, you can by seeing this, how many terms are there? 5 terms are there. It is not in a standard form. Okay. So it will be difficult. कैसे करेंगे? F is given as A bar, AB, AB D bar, AB bar D bar C. So कैसे करेंगे? Here B, C, D missing. Here C, D missing. Here C missing. Here also C missing. Here A, B, D is missing. Okay. So cross means accordingly you need to find the combinations we discussed. So this shortcut method also will become lengthier. It will become lengthier. So again, you don't have that much of time that you will find out this mean terms in this way. Then we will solve the K-map. It will take a lot of time. So how to this instantly, or how in some other way we will be able to do this. So for that purpose, if you remember when we discussed this in today's class, I showed you this example. Okay. So in this example, what I told you, when we formed the octet, how many input we got here in the expression? कितना input था expression में? D bar. How many input is coming?
One.
1.
One.
When we are going for quad, how many inputs? 2.
Two.
Fair?
3.
3. Okay. Now using same technique in reverse way, you will be able to solve it instantly. Okay. So what to do? 1 second. So what I will do, let me first write A, B, C, D, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So it is given in SOP or POS? SOP or POS form? SOP. For SOP, X bar is what? 0 or 1?
Zero.
0. X is 1. So ये 0, 0 को क्या लिखेंगे? A bar, B bar. This is A bar B. This is AB. This is AB bar. This is C bar D bar. C bar D. C D. C D bar. So A bar. Okay, it is a 4 variable K map. A bar. A bar means what? It can be an octet. Now that means here directly expression is given. Okay, so we can think about that what kind of combination will come to this expression. It needs to be octet, quad or pair. A bar क्या होगा? Octet या quad या pair? एक इनपुट है
Octet.
octet. C क्या होगा? खाली C, this one. It also needs to be a octet. AB क्या होगा? 2 inputs है
Quad.
quad. A B D bar pair होगा
Pair.
A B bar A. Is it visible screen? Screen is visible.
Yes, sir.
A B bar D bar. It also is a pair. Okay. Let us start with a pair. Okay. Now think where one needs to be placed such that you will get a pair of A B bar D bar. कहाँ पे वन होना चाहिए जहां पे तुमको A B bar D bar मिलेगा? कहाँ पे वन होता two adjacent ones such that you have got expression A B bar D bar. A B bar means which row? First, second, third, fourth. Check and tell. Am I audible?
Yes, sir. Last row.
A B bar means last row. D bar. D bar means क्या होना चाहिए? कहाँ कहाँ पे होना चाहिए? D bar कहाँ पे है? Which column? First column, second, third, fourth. Where D bar is there?
First and fourth.
First and fourth. So there you can put ones. Here if ones are there, it can form a pair and whose expression will be A B bar D bar. Clear? Second, A B D bar. A B D bar कहाँ पे होगा? A B कहाँ पे है? Which row? A B.
Third row.
Third row. D bar again first column, fourth column. So this two should be one. Just we are doing a reverse way, nothing else. Next, AB. So for AB, four ones has to be present. It has to be a quad. So in which adjacent cells, four adjacent cells, I need to place one such that expression will be AB. AB कहाँ पे है? Which row or which column? Where is AB?
Third row.
Third row. So all third row value should be 1. Okay. Next, A bar. A bar needs to be an octet. So in any 8 adjacent cell, 1 needs to be present such that you will get A bar. So check A is available in the horizontal side, this is left side. So where A bar is available, first row, second row, third, fourth row?
First and second.
First and second. So all that needs to be 1. If all those needs to be 1, then it can form a quad and whose expression will get as A bar. Similarly, C खुद से बताओ where C needs to be present or where I need to put 1 such that I will get an octet of C.
Last
First,
two rows. Last two columns.
last two column. So if it will be a quad, then its expression would have been C. Now see, easily within 2-3 minutes, we are able to fill all the ones. That means what is the mean term? This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, 8, 9. 1 second, गलती हो गया. This will be 8, 9, 10, 11, 12, 13, 14, 15. So what will be that function? That function will be summation of n 0, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. So within only 2-3 minutes, we are able to find all the mean terms. We are able to find all the mean terms by using the reverse method. Next is minimization. So we can minimize this. You can see from this picture how many octets are possible. 4 octets are possible. 4 octets are possible. 2, 1 is this, 1 is this, then this vertical one, third one, then this one is the fourth one. If you check, all the octets are essential. All the octets are essential. Okay. So using this way, you can be able to find the minimized expression. This is similar kind of question, so you can solve. Okay. So this is all about the K-map. Try to solve this kind of questions. If any doubt, ask me. Okay. So next class, we'll go for the next chapter, which is the combinational circuit. Okay.
Okay, sir.
Please practice these questions. If you need doubt, ask me. Okay. So in your textbook only, so
Sir,
many. Yes.
sir, till which chapter are we getting in our medicine?
This chapter and next chapter also will get in the mid semester. Whole
Okay,
chapter.
okay,
Okay, second, this is the third one. Okay,
okay.
so once you know about K-map, same thing will be repeated. Like I solved one example of that LED, so same kind of thing we'll do in the next chapter. Okay, so these things are prerequisite. Once you understand this thoroughly, because next time onwards you will not solve that K-map. I will write the expression. From that you have to solve K-map yourselves. Okay, so in each problem you need to solve the K-map. Okay, maybe it will not be in a standard form, so you need to cover in a standard form. So all these are prerequisite. Once you know this thing thoroughly, so digital is very very easy, it is not at all difficult. Digital is very very simple, but what happens, you need practice. Okay, because like this problem is solved here, if we'll solve this traditionally, if we'll find out using those method, it will take a lot of time. So time constraint is there. For one problem, you cannot spend 30 minutes. So you have to solve it using that 3-4 minutes. So you need to go for the shortcuts. Because not only this question comes, so next chapter onwards, from this, something other designing aspect will come. Okay. So this thing will be there. Apart from that, other things you need to incorporate. So those things of our importance. So you cannot spend so much time for doing all these things. Okay. So just practice, it is not that much difficult. You can practice it very very easy. Okay, so in book try to solve different problems. If any doubt, ask me. Okay. Okay, thank you very much again for all of you for coming this on Saturday. Okay, thank you all.
Thank you, sir.
Thank you, sir.